Okay, for people joining this live stream, we are talking about spatial statistics functionality for version 12.2 of Wolfram language. For those who are keeping track, apparently this is the 400th live stream design review that we have done. So uh, that's a lot of pieces of functionality designed live and in public. And we hope people like this kind of open design process. And you'll see in version 12.2, we'll actually start linking to some of these videos in the functions that have been designed as part of this live stream design review process. Okay, onward, spatial statistics. So where are we starting today?
So one of the things that you haven't gone through, and I think it's useful because you asked about sort of a radial distribution function, which we didn't know what it was, which was pair correlation G. So those 5 or 6 functions there, homogeneity measures to the left, or in that guide page too, those are useful to go through.
Okay, but let's
then we haven't even started in on processes yet.
Okay, but this page, which will eventually be basically spatial statistics, there's something here, spatial bin data. So I didn't look at that. That's
okay. Let me explain the inception.
But wait a second. Should that have been listed here? Is that just a mistake, or is this?
It's a mistake. It should have been listed there.
All right, okay, fine.
And this was the reason we have this is that it turns out that as of today, or for privacy reasons, a lot of data is not available as detailed point data. Sure. So for instance, you might get crime data that's not narrowed down to the actual house.
Yeah, right.
Or disease epidemiology.
Okay, so this is the stuff that geo-region value plot would plot. Is this region arrow value type stuff?
It would be, yes.
Okay.
But now you can compute with it.
And no, so I understand.
What we've done, and this is slightly questionable, but we for many functions, you can actually use this aggregated data. And what we will take, so the only thing you know about it is a constant value. You know the intensity for that region.
I understand.
We simulate it. We then simulate the points.
I see.
Okay.
So like with Monte Carlo.
Yes.
For purposes of things like the smooth point density.
Yes.
In other words, if I've got spatial bin data and then I say smooth point density, I've got spatial bin data for France and Spain, and I say smooth point density, that will show a smooth interpolation because it has effectively created it with points, so to speak.
Yeah. So that will then start going through almost all of our functions. It will translate bin data to point data.
Okay, so hold on. We could as well do that for when we have histogram distribution, right? We could have been doing that there, couldn't we?
Yes.
In ordinary statistics.
So what we didn't do there, but we need to go back and do, and that's come up from user suggestions, like for histogram, to take pre-bin data already, because you often get it. Mm-hmm. As I said, like traffic data, if you get traffic counts, you often get it per,
Okay, so hold on. So what you're proposing is that we have something, so there's a whole calculus of bin data, presumably, because given 2 sets of bin data, you could add it together. If the bins agree, it'll, the values should add. If you have disjoint bins, you should be able to combine them and so on, right?
So we've not tried to implement a calculus like that. It's pretty bad what happens, the growth with when bins don't agree. You typically get sort of the product of number of bins, and you keep getting the product. So it grows exponentially typically.
Okay. Question. I mean, we have somebody implementing this MCMC Bayesian technique and so on. Is that relevant to this whole story, or is that something irrelevant to the story?
We have our own MCMC engine that we wrote. So that's simulating a lot of these processes. Now, when we do
well, wait a minute. How is that relating to this Joseph guy's MCMC project that Sushma is dealing with?
I have no idea. We did this many years ago.
Why didn't we expose the MCMC method then?
Well,
I mean,
people have really wanted that for epidemiology.
This is a very custom. This is very custom code, very optimized for the task at hand. It's not very general.
Specific place. Okay. All right. Fine. Okay. Can somebody make that connection, please, with Sushma and Joseph, so that you can at least see what he's done?
Yeah.
No. Do I need to send mail about that?
Yeah, do send mail.
Okay, but you know what? We need a project manager in these meetings. That's kind of the deal.
Yeah, I mean, I can send the mail for that.
Yes, please do. That's kind of your role here. Okay. So, let's go back talking about bin data. So do you imagine that beyond spatial bin data, that there is another, there's just a function called bin data?
Possibly, yeah. So we have something right now which is much more limited called histogram list, which is sort of an output that does the binning for you. But I think we need a container like that. If we have the container, then a lot of functions could just work on it, like histogram with all the styling.
Yes, I agree.
You know,
this is broken, by the way, for the 12.2 prototype build. This open function page thing is broken. Matt, are you able to? Well, maybe it isn't. I don't know.
I got it.
I didn't know about this function. What is this? Oh yeah, I remember what this is. Yeah, I remember this.
Yeah, and it can only do rectangular bins.
Right, so it doesn't do histogram binning in 2D, 3D, and so on.
It does, but they're rectangular.
Mm-hmm. So it can't do it into regions, basically.
No.
Now, presumably that B-spec could be generalized to regions, yes?
Yeah, it's very hard-coded to some product.
No, but that's not, you're not going to make a new function for this. I mean, we got a function that does this, right? That makes.
Yeah, but that's not the problem. The data is coming in as the output from this function. This one is.
I understand. This is taking point data and turning it into histogram data. So this is creating binned data, so to speak, except presented as a list.
Yes. So
what this is representing, so spatial bin data here is representing something which is, there's one thing which is the binning process, that is saying I want to bin things by country, for example. Here is my raw data. I'm going to bin them by country, and then I only want to manipulate it bin by country, right?
Mm-hmm. Yes.
So, okay, so there's one thing which is the creator of this, and then this is the container of data binned by country.
Yes.
Right. So why isn't this name spatial region data analogous to spatial point data? I mean, spatial point data describes the things at which you have data, right?
Yeah, I mean, but
and I don't quite understand why spatial point data, is basically, it's either a point. I mean, how does this relate to, for example, what happens with time series and temporal data and so on, where you can in principle specify, I mean, we have the exact same issue there. You can either say this week, the weather was good, or at this instant, the, sky, cover was such and such. Am I making sense? How are we representing those two things?
I don't know.
Well, so I'm talking about granularity. If we've got a time series or a date series, an event series, okay, and we've got date objects with different granularities, right? So let's say we have a thing with a granularity of a week, and it says that there were 5 people, or there were 5 toads in the enclosure that week. Okay.
Mm-hmm.
So, but that's a weak granularity thing.
Mm-hmm.
As opposed to at this instant, there was, we observed this toad in the,
Yeah, I see what you're saying.
In the pond.
So I don't know. I mean, the depends on what your question is. The question is, should we simulate that data up?
No, that's not my question.
My question is, be very careful about that.
Yeah, no, I agree. I'm asking a different question. I'm asking about these containers, and I'm asking what is the structure. Look, what we've got here is we've got the idea of point data, right? Okay, so what we've got is data which is of the form where, arrow, what, right? That's the basic form of our data, correct?
Yeah.
Okay, so the where, in the case of many of our functions, is just a raw coordinate value, right?
Right.
But the where could also be a geoposition, etc. The where could also be a data object.
Yes.
Now, one feature of a data object is it has granularity to it.
Right.
Right? That is similar, but not the same thing, but it's a similar thing to this region thing here for georegions.
Yes.
Okay. I could also imagine something in a different world of computational geometry where you are saying things like polygon has this value, right?
Sure.
Where you've got something that represents. So my question to you is, why is this not a general spatial data concept where the left-hand side is just where and the right-hand side is what? Do you see what I'm saying? Why are we distinguishing between
points and regions?
Yes.
Well, they have very different behaviors. I mean, to begin with here, right? As from this perspective of point data, there are many points in a region, or potentially many points.
No, I understand. Look,
so they're not the same.
I understand that. Okay.
But why do you want to I mean, I don't know what you gain by unifying them, except an awful lot of complexity is going to be pushed to the user.
Well, I think the opposite, actually. But I mean, the question is, what you're saying is, in this case, what we're doing. Okay, you're saying in this case, it is binned but simulated as points.
Yes.
Is that correct?
Yes.
So it's not completely obvious to me that that name makes that clear. It's somewhat reasonable.
The place that we're coming from, to the spatial bin data is that, as Roger explained, it's the aggregated data. And so the important feature is that, think about this as a bin, so that the regions are disjoint. So you kind of have your, covering of your, observation, area that you have. And so you have these regions.
I get it.
So this, and then the assumption is that you can think about simulating this, in the way that it's uniform over your regions, and then work with the other statistics.
I got all of that. I get all of that. So what I don't get is why one is called spatial point data and the other is called spatial bin data, which is simulated points but doesn't have the word point in its name.
Well, we could call it spatial bin point data.
Maybe we should.
Maybe we should,
because I don't think that the
I think it's a pretty good idea, actually. I feel more comfortable with that because we're going to have. I mean,
that's a complicated concept, and I think it's the right thing to do, rather than
make it. Yeah, I think it's too. It's amazingly much data that's published by zip code or some such.
Absolutely. Okay, so then explain. I think we happen to have Jose here, and I presumably for the geo part of this. Can Jose comment on the time series and date object part of this story? I mean, is there a similar thing that we'll want to do for time series?
So I think the case of dates is special in that we have merged the instant case with the discrete case, right? So in general, we didn't mix like numbers with intervals or points with regions, etc. So dates is special in that sense. So it is an exception in my view, rather than
okay. All right.
present.
Listen, by the way, in terms of note taking here, am I taking these notes basically? Shall I just take these notes? Do we have does anybody know where I'm putting these things? Anybody even know that?
Spam protection.
Probably not. Okay. Anybody know that? Come on, that's a pretty minimal thing to know from a project management point of view. Nope. Nobody have any idea. Okay, fine. All right. Okay. So.
Yeah,
all right.
So just to finish the comment, I think in time series, the thing will be just to require that we have something of a definite granularity, and then we can just use dates of common granularity. It's the same thing we are doing with date interval. Date interval contains a granularity, so we just project things to the granularity of that date interval.
Right. Okay, let's see. There are comments on our live stream here. Okay, Ethan is asking about LiDAR clouds with tens of millions of points.
So that's not here. I did a study of that. Those kinds of point clouds, they're primarily sampling a continuous surface is what the point of that data is. That's the kind of thing that's returned by, for instance, some of our image import functions now, like Hive import can import effectively depth values. And
the issue is the scalability of this stuff and things like, when will Graphics 3D be able to deal with 10 million points? I think it's a different team.
No, but it can deal with that today. And we deal with 5 to 10 million polygons and so on.
Fair enough. Okay, I see here is asking about geographic positions of lightning. Will I be able to compute the probability of my house getting hit with lightning? A reasonable question. What would you do? Given that scenario, and by the way, the lightning database is a nice database of point data. Well, that's points as a function of time, right? Do you know what I'm talking about?
Yeah, but we would take out the time. We would just use the point.
For now, we're taking out the time.
Yes.
But in the future, what do we imagine? If we wanted that with time, what would it look like?
Don't know. I mean, we have to think about sort of spatial.
I mean, the question is whether it's time outside or time inside, among other things.
Yeah.
Both of those you can imagine,
Yeah. Time is usually treated differently, generally speaking, in all of statistics, because you don't usually want to predict from the future. You don't want to use data from the future to predict. You want to use data from the past to predict. That's very different from spatial, where you can use all the data around you.
Yes, well, right. Let's not go into the discussion of the physics of time, but yes, very different concept. Yep. But in any case, okay, but I mean, what we would imagine there is that we could imagine a time series of spatial point data at some point in the future. Is that right? Is that what you would have?
I think we need something else than time series for what all the wild things that we're starting to call time series. I realize that we need it, but it's not going to be time series where you can actually operate on it then. It's just going to be a container thing, a very general thing. And then you can have a time series of footballs and ears and chemicals and whatever you want.
Yeah, well, it'll need to use that name, but it might work differently.
Yeah, it will work differently. And it will be more of just a container, and it will be sort of a small.
Yeah. So we have that actively being worked on at this point, time series?
No.
Ouch. We need to talk about that.
Yeah.
One comment for the particular case of events, points in time, geoposition can handle time. So it's possible to just store a geoposition of lots of events with timestamps.
Ethan is saying that it isn't true that we can handle tens of millions of points in Graphics 3D.
Okay.
And that is pointing out that needs to use GPU acceleration, which Graphics 3D, does not have in the kernel. It presumably has it in the front end.
Yeah, okay. He might be right.
Well,
I mean, but there are obvious things. It's like, did you do a point wrapper around each point, and then just the expression creation will kill you. If you do a point of a list of packed array data of 10 million points, then there's a good chance it could do it. Right. You got to get about past all of those things first.
Right. So
and if they're totally random, which they usually aren't from LiDAR cloud, they usually sort of form some continuous surface. So they can actually show something decent. If they're just random, I think you'll just see black. I mean, you'll see nothing. That many. But if they're points sampled on a surface, they're going to make that surface look almost continuous.
What's a good function to put in here? Normal distribution.
No, random variate. Probably you want. You can use.
Can I do random variate on a surface?
No.
Well, I can do random point on a surface, can't I?
Yes.
How would I do that? I would just say random point on what? On sphere or something.
Yeah, for instance.
And then I would do like 10 random points on a sphere. Okay.
Yes. Yeah.
And then I would do like, let's do 10 to the 5 random points on a sphere. And then let's say point of that. And then let's say graphics 3D.
Yeah.
Of that. That was pretty zippy.
Yeah.
That was very impressive.
Yeah.
That's 100,000 points in no time.
And if you give them, if you also give them 100,000 normals, that will actually look nice.
Well, this is already, I mean, that was quite impressive.
Mm-hmm.
So, I mean, if I, yeah, there we go.
But see, if you give them normals, they're going to look continuous. You're going to start seeing the actual surface.
Yeah, I don't care about that. I want to just try. Let's just try. Should we try 10 million? Why not?
Sure.
It's grinding. It's spinning.
I don't know how much the random point generation is taking of that, but it's probably taking some significant chunk too.
Yeah. Oh, I've zoomed. That's right. I've zoomed in here. Okay. Well, it rendered 10 million points. Okay. So Ethan is saying that the things he's sending are 100 times faster than this. Okay. Well, we should look at it.
Yeah.
But I don't think it's for this team.
No. I mean, there are dedicated point renderers that are trying to render just that. This is sort of a scheme of rendering, point-based rendering. And then, of course, it's fully optimized for that.
Right. And you're not putting in a notebook container and so on. Well, this is, okay. Anyway, let's go on. This question about geographic position of lightning, somebody's asking how is the lightning measured? Actually, it's measured very generally in the world. It's because it's very easy to tell where lightning is. You just look at the you just look at electric fields, right? That's how it I think we there's a lightning database.
Isn't that one of the data sets, Gosha, that you have there?
I don't have lighting, but the question kind of, it's what's the empty space F is computing. So that's the, like when you have a tornado index on, on the.
Right, we should have a lightning data because the fact is there is very good lightning data.
I will look it up and see.
Yeah, I mean, here
I can curate.
I've got here's a NASA one. We have somebody who's going through all these NASA databases, trying to make them available in our GeoImage functionality. Okay. Right. Huh. That's a decent suggestion, providing an application section that shows a large database being used in particular for different functions. Yes. Okay, let's see. A comment from Sander here. Okay, so this is the question about bins, multiple overlapping bins, and what happens, how we combine bins. But that's not what you're doing in this case. In this case, you're simply resampling. Is that correct?
Yes. But there is a question of user input. If the user gives overlapping bins, what do we do? Do you know what I'm saying?
Right. What do you mean? What do you do?
Do we try to? It is super expensive to compute all the cross intersections and resplit them. I don't think we are doing that at the moment.
No, we are not.
Well, but you can do it by Monte Carlo, yes?
No, but the question: how do you treat the input that has overlapping bins? Yeah. You know, should we check that? What should you do? Should you trim the bins to be, you know?
If you're doing Monte Carlo, why do you care? You're just sampling in the bins that are specified, aren't you?
Yeah, but if they overlap, you know, you're saying that.
So what? I mean, what does that mean?
Here's like 2 geographic regions. The number of disease cases. It could be that some of them are.
I see what you're saying.
Means
the question is how it's included.
A function with 2 values, and so what do I choose?
It's the same thing, right. So it's a question of, it's like region combination. It's like constructive geometry, right? Is it the XOR of the regions, or is it the union? You know, is it the OR of the regions?
Right. And so right now we require that there be a disjoint. I mean,
but the alternative, the easy thing to do from a Monte Carlo point of view would be to do the OR of the 2 regions. Correct? But you're just sampling points.
Sure, you can do that. But is that what it was intended? What was that?
I don't know. But I mean, what you're saying is the alternative would be that you notice that a particular subregion is double covered, and you sample only once. But if you've got 2 different values, if one region, you know, if France, well, what's a double covered region? I don't know. We could say, I don't know, New York City versus the state New York State. Okay, so New York City had a value of 10 and New York State had a value of 1. Those were the density values for those 2 places. What do we do in that case?
Right.
So that's a good question. It seems to me that we should know, you know, that issue has surely come up in the work we've done on endless sort of Census Bureau data and so on. I don't think anybody in this meeting would know about it, but it will be interesting to ask Alan what has happened in those cases.
Right.
Unless Jose knows something about that. Because that's certainly come up. It will have come up in our analysis of COVID data and all kinds of other things, of what to do with backing out overlapping regions. So can you follow up with I think Michael might know something, Alan might know something about that. But what you're doing right now is you're generating an error if the regions overlap. Is that correct?
I think so, yeah.
Gosha, can you speak to that?
We might. I mean, we basically right now, you know, take in the whole goodness and then see what happens. But we would like, you know, to check that. It's just super expensive. That's what Roger said. So, you know, if we
wait.
Well, so the point is
what we started in this discussion was that you don't allow overlapping regions, but now you're saying you don't check for whether the regions are overlapping.
Well, so there is a problem here between, you know, a user who provides a non-overlapping regions and wants the thing to go fast, and the user who doesn't know if the regions are overlapping and wants. So I think we should basically give an option where you check for that, like you check assumptions. So you're gonna check that, and then we're gonna check for that, and it's gonna take longer, and it's gonna be expected.
But what does it do by default?
So we have some code that is disabled. So I commented it out that would check for overlapping. Right now, it's no.
I understand, but what does it do? What is the mathematical definition of what it does right now if you give 2 overlapping regions? Does it take?
I think it assumes that they are not overlapping and then proceeds, you know, so you get incorrect results.
But it will error when.
No, you're not answering my question. If you're doing Monte Carlo sampling and you've got a region which has a 1 value and a region that has a 3 value, what are you actually? You're going to sample both of those, so you're effectively getting a 4 region. In the overlap is effectively a 4. Is that correct?
Yes.
Okay, that's fine. That's a well-documentable. Yes, that's documentable. That's what it does. If you don't want the regions to overlap, then either make sure they don't overlap or set the option to check overlapping.
Yes.
That's actually reasonable. That's actually a really good solution. Thank you.
But we also have some code that uses mesh regions, and mesh regions have to be constructed correctly and not overlapping and on that. So there will be a clash in behavior between giving a list of regions and giving cells that will be mesh regions.
What do you mean?
No, Eduardo. The mesh regions would guaranteed be non-overlapping. There's not going to be a problem.
Yeah, like mesh regions work. Like if you try to construct a mesh region that is overlapping, it won't work.
No,
that's what I'm saying.
Exactly.
Right, but it won't work at the source because the mesh region itself won't allow overlap.
Exactly.
Okay, fine. Yeah. So there's no issue.
It's not a problem. Yeah.
Right. So, but I mean, in the case where we check for overlaps, given that we're bothering to check for overlaps, why don't we just define what the overlap function is? Do you see what I'm saying? So the overlap function could be average. It could be take the larger. It could be, all the obvious things. Right? I mean, does that make sense? So then the default is simply or actually the default is basically plus, because it's what do you do for the weightings of the two things?
Yes.
And, it could also be max. It could also be,
Yeah.
0 for if it overlaps, all those kinds of things.
Yes.
Okay. Okay, let's go on here. All right. So we agreed we're renaming these things mean density, mean point density, right? That's that one, mean point density. And so then in the case where you say mean point density of a spatial binned, mean point density of spatial binned point data within a specified region, right? That these take a second argument, which is the bounding region. Is that correct? Is that correct?
Look at it. I don't know. I think that
should do.
I think it doesn't.
Oh gosh, this doesn't work. Oh, mean intensity. Did you rename it or something?
Mean point intensity.
We changed it in the guide, but I didn't change it in this design. Notebook. It's been many name changes.
Okay, no problem. Why don't you allow it to take a second argument with a region? That seems useful to me.
What would it do?
It gives you, okay, so here's the situation. You've got a big data set and, of Europe showing the bin, gridded population for Europe. And you want the mean point density for France. In other words, you're cookie cuttering out, that region.
Yes.
Does that make sense?
Yes, totally. You just select the points which are lying in your subregion, and then you compute, the number of points you get over the area of your subregion. Yes.
Right. Seems sensible to me.
That functionality exists. We may also extend it here to this function. Yes.
The functionality exists by wrapping spatial point data with a region around your point data to basically.
Well, to sub-select that, yes, but also we can compute certain information from spatial point data. So yes.
Okay. Now remind me, spatial point select.
Well, that's a different story. That it's to select by points and values of annotations. So
but wait a minute, how do I get the criterion to apply to the value itself? I mean, this is like a key value select, right? Because
it's for that
point.
Oh, this is the thing which we called hash point, which I was complaining about.
Mm-hmm.
Did we solve that or not?
I thought you were okay with it at that point. And the thing that you said, that the very common case of constraining to a region, actually spatial point data, comma region does that.
Right.
Which we had implemented, which you suggested also.
Yes.
But we had both come to the same conclusion.
Mm-hmm.
Okay, but now this thing about hash point, what is the Conditions on the point. What is the thing being fed to hash point? Is it a point or is it the coordinates of the point?
So it's the coordinates of the point if it's just one of these, Cartesian, and it's a geoposition if it's a geospatial point.
Yeah, right. We went through that discussion before. All right, I'm okay with it being called point, I guess. But don't, for goodness sake, you got to emphasize. Oh boy. And in the case where there's a key called point, what does it do?
I don't know yet. I need to think that through.
Okay. All right.
I just assumed very unlikely case, but I'll think that through.
Yeah.
So,
no, I mean, one is going to take precedent, and I
Yes.
assume that the sort of the keyword point here is going to take precedent.
I think it has to. I think it has to.
Otherwise
Otherwise you can't get to it.
Yes.
Yeah.
Okay, fine. All right, let's keep going here. All right. I think we went through all of these point density functions and so on. We went through all of that stuff.
I think so, yeah.
Okay.
What we didn't do is the homogeneity measures. And point count distribution we haven't looked at.
Right, let's look at point count distribution.
So that takes a point process in, rather than a point set.
Okay, by the way, Ethan is asking, do these work with the same annotation framework and regions of interest as in images and plots? In other words,
it works with the formal annotation framework, yes.
In what sense? So can
we
I
haven't added annotations to images yet. We have added annotations to audio, graph, and a geometry region. Mesh region.
Actually, so Ethan is asking, does it support highlighting?
No.
Should it?
Well, you can specify, certain, annotation per highlight. You may say 0, 1, and your ones will refer to the highlighting. So you can
You can achieve the same effect, but there is no highlight function because it's not visual per se.
Yeah.
Sorry, say that again about how you achieve it.
You can use an annotation. You can call it highlight or whatever it is.
Yeah, right.
But there are two different kinds, and they will be colored differently, when you use those attributes. But point value plot will color them or show them differently.
Yes.
Which you can control how it does that too.
Yeah.
All right. So point count distribution. So this is you're throwing darts at something, and this is telling you. This is like your Gaussian distribution of darts or something, is that right?
Yeah, it's not Gaussian in this case, it's most likely Poisson. When we have the Poisson point process, that's going to be a Poisson distribution, the number of points. So in every realization of the point process within the given region, you get some number of points. This is a random variable, and this random variable follows a certain distribution. And so for like Poisson point process, this is a Poisson distribution. And for some other processes, we don't have the closed form, but we can represent it as a transform distribution. So in a way, point count distribution is a derived distribution. And even if we don't have the closed form for that, we can, if things are numeric, we can simulate that, right, for the point process simulation.
Okay. So
in which case you get the non-parametric distribution.
Right. Yeah.
Okay. So wait a minute. If I say point count distribution of a Poisson point process, that's a two-dimensional one there.
Yes.
We happen to know it for this particular region and this process. We happen to have a closed form.
Right.
But if I were to take there a rectangle, for example, I mean, I don't understand this very well.
It's going to give you the mu. That's a Poisson distribution where the coefficient, the parameter in the distribution is mu, the coming from the Poisson point process times the area of the region. In this case, so the measure of the region.
Cool. I like the pentagon better. Okay, so this is you're throwing things in there, and the point count distribution is telling you how many counts you will get within that region. Is that correct?
Yes.
Yes.
And the
so
process.
Here's an interesting thing, Stephen.
Yeah.
you could say that if you knew the point count distribution for all possible collections of regions, not a single region, but you can see the next use case is when you have multiple regions.
Mm-hmm.
If you know all of those, you know the process. There's a very infinite stack of possible things you need to know.
Yeah, I understand. But essentially, those regions of is in the end, they slice space down to particular positions, right? So you're basically saying, by the time you slice space to the point where every spatial point is a separate region, you know what the process is. Is that what you're saying?
Yeah.
Roughly speaking, yes. Yeah. This is the analog for random processes. If you know all possible slice distributions, multi-slice distributions, you know the process. But that's a very infinite number of things you need to know. But it is a general way to define it.
Okay. What are some of the, let me look at these things on this process page. So estimated point process.
This took us some time. That's given data. Can we fit the parameters for those mechanisms there?
So this is given the parameter, given that it's a Poisson distribution, can you determine which Poisson distribution it is? Is that right?
Process,
yes.
Point process.
Yeah, but in this case, this is a process. So you throw it, say, Poisson point process means that you expect, uniform distribution from that. So you want to know what's the density, the parameter in your Poisson point process. If you throw the model which is clustered, then we're going to try to fit the cluster parameters, and the problem is that it's sometimes hard to recognize. So we don't, we don't have the recognition that will tell you immediately this is a cluster process or, it's a uniform. That's the spatial randomness test. Here it's just exactly saying, okay, I want the best parameters for this model, and that's what it is.
How are you specifying that's the mu you want out of this?
Like that, it's a variable.
But how don't you have to give comma mu here?
No, you just gave it there. This is exactly how estimated distribution.
I see. So that's just that the name of that variable is completely dummy.
Yeah.
Yes.
That's interesting. We don't have a lot of functions like that essentially solve for a variable, but the variable is just being there, just sort of being I mean, that's how we would usually use blanks, for example, to represent an unnamed, more what I would more expect.
The thing is that what this allows is that multiple ones that can also be the same and so on.
Yeah, but why not use blanks? I mean, I would expect that would be the thing there, that this is it is filling in something of that form, and if you want them to be the same, you use the way that pattern matching, determines
that somehow comes together, that we also have find point process parameters, which needs to know what the parameter names are, and that returns the rules for all your named parameters.
Fair enough. Well,
so then you don't want to have a different inputs, because then you can use them interchangeably. And with the blank, you will not be able to tell blank which blank is which blank.
Well, yes, unless you name them.
Exactly.
With X blank, which is more like the cases situation.
Right. So that's why we have names, to avoid that confusion and have consistency.
I'm not wild about that, but anyway, okay.
That's the same for random variables and random processes.
Mm-hmm.
Okay. A Gibbs point process. What did old Josiah Willard get up to there?
It's actually easier if you start with all the other ones are basically instances of this. So this is the most general form it can take. By the way, Gosha, you see that call box is wrong. There's something styled with that.
At the call box?
Yeah, see the alignment there is just totally wrong between the input and the text.
Yes, right. Oh, it's not indented.
Yeah, okay. I don't know.
I don't know.
Okay,
I'll have a look.
Does this come from statistical mechanics? I mean, is this based on? I mean, like, does this expect to have things like a Leonard-Jones potential in it and things? No. What is this? What?
I mean, it comes.
Well, I mean, I think the guy that developed the whole originally, yes, but no, we don't have that potential.
Well, but the radial pair potential function 5R means you could put a Lennard-Jones potential in there. Right, you could put R to...
Yes, yes. It's not a standard model that we have, but yes, you can.
But I understand. Your standard model, it says pair potential here. So
sorry, by standard model, we have a family of models that are all under the Gibbs. The Gibbs is like the general Gibbs.
Oh,
these
I
are the family.
Yeah,
yeah,
right.
Yeah.
Let's see. There's a question from Bob. Can you plot points on a globe rather than just a map? I think that's coming, isn't it, Jose? Don't we have a GeoPlot 3D coming? Geographics 3D?
Not in this version, but yes, eventually we will have the 3D versions of Geo. And the language for heights, vertical, datums, etc.
There's a question from Robert here. How would I combine a large circuit graph like an electric grid for utilities with these spatial statistics primitives? E.g., if I wanted to project consumer growth stochastically and then compute the effect on grid failures. So in other words, how do you put a graph, how do you layer a graph on top of spatial statistics? Interesting question. I mean,
it is an interesting. So here's a potential. I'm interpreting what he's looking for. In some cases, like the example he gave with utility lines, with electrical lines, but also traffic, they mostly happen on effectively a graph. So then you don't want the full space, but you want it restricted to those 1D. So you want to change all the measures to be the correct thing for those.
I think that's a different problem. I think that's another interesting problem. I don't think that's the one he's referring to. I think the question is, can you align a graph? In other words, okay, so first point is, our notion of geograph is coming soon, not here in this version, but a geograph will be something like the street network for a particular city, which is a graph whose coordinates are pinned to geopositions. Right, Jose? Am I representing that correctly?
I think that's correct. So currently we can have a graph in which the nodes are geopositions, and then geographics will just add paths.
Really?
Yes.
Really? So if I just say, if I pick, how do I pick a random geoposition? Let's say random point. How do I do this? Let's say France or something.
I think it's not random point. It's
random geoposition.
There is a random geoposition, yes. Random geoposition of command 10. Yeah.
Okay, right. And then if I do the following, so what you're saying is, if I say, can I break these apart? Does normal break them apart?
Not normal. Just do thread.
What?
Thread.
Really?
Thread. Yes.
Okay, and now if I say something like nearest neighbor graph,
I'm not sure what that's going to do.
Is that not computing nearest neighbors with respect to geopositions? Okay, oh, whoops, I should have said comma 2, but now, okay, this is the question. Can I say geographics of this?
So do geographics of line of that. Assuming that the nodes are still geopositions, which I'm not sure.
Wow. That's a good example. Very nice. Well done.
Right, and the idea is that you can say, instead of line, you could say geopath, loxodrome, and it would draw loxodromes. Or you can say point. If you just want the points, if you change line to point, you just get the points of the.
But what's the loxodrome? That sounds cool. Geopath.
Yes. I mean, for these short paths, it's going to be nearly identical.
What is it called? Loxodrome or geodesic?
Yeah, loxodrome is yeah. But for these very short paths, you don't see the difference. If this was through the wall, it will be noticeable.
Right.
But the key point is that you have to specify outside the primitive you want. You can say point, and then you just get the points. Or you can say geomarker, and you get geomarkers.
Right. Well, this is very nice. You should make sure there's an example of this someplace. I had no idea this would work. Okay. There's a question here about whether, well, this is again, can we draw graphs on surfaces like spheres? Or do we have that capability? Roger, that would be.
We did it. No, we don't ship it. We did a few of those. Actually, maybe it's available as an option, but we haven't extended that systematically for any shapes. We did it specifically for spheres, but not more general.
Right. We are running out of time here. I just want to make sure we get a quick look through this point process stuff. So fundamentally, the way these point process things work is you're saying this is the process, and you're sampling the process. Okay, yes. What is random point configuration? We went through that before, right? That's the random general process.
Yeah.
That's the analog of random variate for a configuration of points.
Yes. Right. The thing here that you might get sort of used or find strange, you need to say where all of these processes are defined on an infinite domain.
I see. So if I say random point configuration, let's say I say random point configuration, and now what do I want? Random points, a Poisson point process in a pentagon. How do I do it?
You do
Poisson point process, and then the region, comma region. It's just that the mu has to be numeric, so give it 10 or 3 or some number.
Okay. And now what I would do for this, now how do I display this? I just say graphics of this, or what do I do?
Well, you can do list plot, for instance.
List plot, but as I said, you need to extract the points for the time being in the prototype. So the property points.
Oh, that was the branch flash.
Yeah, I need to resolve how to deal with the.
So how many points am I specifying here? Am I saying
34? So this is part of the process itself, specifies how many points are going to be in that region.
So if I were to say 100 here, that would mean the Poisson process that has more.
More, because you see that the number of points is the Poisson distribution, right, that you have below. So if you put the point count distribution and you in place of mu, you put 100, you're going to get the Poisson distribution. And the parameter there, it's going to be the expected number of points in that region.
So if I say spatial point data of, oh no, if I were to do this, presumably if I were to say mean, what you're calling mean point intensity of that thing, I'll get 100.
Yes.
Good. Okay. Very nice. And is there a variance concept as well, or is that not something people consider?
So not really the second order, this is what we call the homogeneity measures. This is the second order statistics, between 2 points or between the location and a point.
Okay, so if I say Ripley K of that, what the heck
that's a function. So if you could put as a second argument R or at R, then you're gonna get a function of radius. So this tells you the kind of expected number of points within radius
R. Why is there no 100 in there? Why isn't there 100?
Because it depends on the radius. So if your radius is numeric, then you're gonna get a number.
No, I understand that, but the fact that I'm saying that the average of the Poisson distribution is 100. Why is it not 100 times the area?
Per unit area, right?
Yes.
Oh, it's 100 per unit area.
Yeah.
Well, so that's.
No, but then why isn't it 100 times the area?
Because Ripley K is normalized. Go and look at Ripley K. There's a normalization in Ripley K.
Okay, fine. All right, I don't need to know that. But okay, so then let's take the pair correlation function.
Well, the point is that, okay. Because this process is special, right? So this has the constant
Poisson point process is like the normal
process
process in this world, Stephen.
Yes.
Everything is sort of everything is clean and simplest with the uniform or Poisson point process.
Okay, so if I take another process here, this hardcore, whatever it is, process.
That may not have the formula defined. There may not exist the closed form formula. You can only simulate and find it.
An empty list of points. Spatial point data, hardcore process of this is an empty list of points. So I see. So this is saying I can't directly apply pair correlation to this. Right, whereas I could directly apply pair correlation to the Poisson point process. It's not allowing me to do that.
Well, I think that's a bug because we simulate that.
Okay,
yeah.
so
you cannot do this with the non-numeric inputs to simulate, right? So this is symbolic R. So we don't have a closed form, so we cannot give you anything.
But that beeped as well.
Well, that's gonna be a problem for us, yes.
Okay, that's a bug. All right, can I just try one more process here? What would be your most likely to work process? A Thomas point process, whatever that might be.
Right.
Yeah, those have closed forms for some of these second order.
Cool. Very cool. Very nice. What does it say? Indeterminate. True. That doesn't. Oh, I see. It's indeterminate if R is not greater than or equal to 0.
Right.
Are you really bothering? Is that really worth saying?
Yes.
Really? Well, I would have thought that was a generate conditions arrow true, and by default it's not there because, you know, anybody who's computing a pair correlation function with a radius and the radius is negative is silly.
We have to be, you know, silly proof in a way.
Why?
So if you give -2 in place of R, what do you expect?
No, then I expect indeterminate.
Exactly.
But my point is this. For the symbolic form, you should have a generate conditions option, which should be false by default. Roger, don't you agree? I mean, because this is the thing. This is what I want to see. I don't want to see all this weird nonsense.
Yeah, I got it. We probably should. We haven't done that with any of this. We've just expanded a lot generate conditions of the last few years in the calculus and algebra, but it.
Yeah, I think you should do it for statistics. I mean, this is the nice thing to see, not this big mess here.
Sure.
I mean, do you have an assumptions option in here?
No, neither assumptions nor generate conditions because they sort of rarely work with parameters.
Yeah.
Yeah.
They haven't been. That's not their primary. This is in this field. The areas where you can get closed forms are few and far between.
No, I agree.
This basically these measures are, you know, heavily used on data to analyze data.
Right. I have to go, unfortunately, because I have to give a talk soon.
Where do you think we are, Stephen?
On this, I think we're 1 hour away from finishing. I think we're very close. But can we see it another time with the changes that we've already spec'd in it?
I think that it's not going to happen now until after the conference, unfortunately.
Right. Well, fair enough. But I mean, I think we're very close in terms of, you know, implementation. We should be good. I'm a little concerned about the names of those. What am I saying? The names of the properties in spatial point data seemed a bit hicky to me last time I looked at it.
Maybe we focus in on that next time.
Yeah, these ones here seem a bit, I mean, like dimension we agreed isn't dimensions, right? We went through all of that stuff. Maybe the rest of it will be. This I didn't really believe in. Points versus points list I'm concerned about. Fair? So yeah. Can we get that on the agenda? And okay, a couple of comments on our live stream I just want to look at. 4D is asking, suppose you work at a refinery and want to overlay a graph of your process equipment on a map. Would that work? I think so. I think that would work just fine with geographics.
I think so too.
With images of equipment, absolutely, it should work just fine. Ethan is suggesting a meta point. Maybe we should do some of these meetings where we try and solve a real world problem with our tools. Sometimes we do that actually, but they're different kinds of meetings. But it's a let's see. Okay, Bob is commenting. how would you draw a histogram linked to a map so that each country has a cylinder coming out of it representing the country population?
I'll say the many people that have drawn those. I wouldn't be surprised if there is a Wolfram function repository thing.
If there isn't, there should be. I mean, that's the 3D version of georegion value plot.
Right.
Do you know, Jose?
I don't know, but it's perfectly doable with a bit of work. Yes. I'm thinking, for example, of that nice video that was created for the marathon in Chicago. Do you remember when in which the cylinders were actually moving along the marathon path? So
right.
Yeah, it's doable.
No, okay. Georegion value plot 3D would be the thing. Maybe we can suggest that if you feed that to Sushma's list of possible things for the function repository to begin with. It's a good idea. All right, I need to run.
Okay, thank you.
Great stuff, and thanks to folks on the live stream also. Lots of good comments.